Query Waste incineration. The chronic poisoning of the people, Part 8. What do engineers and chemists say? The various types of incineration technology and flue gas cleaning which were researched are described in detail, including advantages and disadvantages in several specialist books and textbooks about waste management and environmental technology. The particularly difficult subject of the formation, measurement and environment importance of PCDD and PCDF were discussed by experts led by the Association of German Engineers, VDE, and was then summarized in two detailed conferences transcripts. The VDE assumed that the pressure on the environment caused by polychlorinated dibenzopidioxins and dibenzofurans could pose a serious danger to humans and animals. These substances are exclusively byproducts by the production of chlorine-based chemicals or the result of incomplete incineration. The PCDDs and PCDFs reach the environment from broad sources. They can be found practically everywhere, in the air and the soil, in the water, in animal feed, and in humans. There was no proof of halogenated dioxins in the environment until about 1920. They have been spreading since 1950 or so. As these substances are not used for anything and are useless too, everything must be done to ensure that they vanish from our environment, from our food and from us. A. Formation of PCDD and PCDFs. Sometimes the World Incineration Plant Lobby shows technical tendencies to attribute a certain decline of dioxin furans concentrations in the environment, even in sample of mother's milk, to the fact that waste incineration plants are pollutant sinks, saying that the decline in recent years must be credited to waste incineration. At VDE conferences, such argument would have been contradicted strongly and countered with references to the ban of leaded petroleum fuel. Apart from lead tetraalkyl compounds used as anti-knock agents, this fuel contains halogenated scavenger compounds, a mixture of dibromethan and dichlorethan. They were supposed to prevent lead residues in the engine. At first, it was thought that the scavenger compounds would be completely decomposed in the engine. However, studies have since proved that among other things, brominated chlorinated dibenzodioxins and dibenzofurans were formed in the process. So the leaded fuel was quickly banned, not only because of the lead emissions. This explains a certain decline on dioxin concentration in the environment samples, but these should not be increased again by more waste incineration plants. Both VDE conferences confirmed that 210 isomers congeners of dioxin furans are known. Apart from the chlorinated dioxins furans, there are probably just as many with bromine and fluorine substitution or mixed halogenated dioxin furans. Their toxicity was estimated as being just as high or even higher. There is no information available on the toxicity of the mixed dioxin furans containing chlorine plus bromine and possible plus fluorine. The medical experts from the Waste Incineration Plant Lobby unfortunately have never mentioned these brominated, fluorinated and mixed dioxins furans. From a medical point of view, this is a grave omission. This could be an omission with legal consequences because the official control laboratories for waste incineration plants only test for the chlorinated dioxin furans. They ignore the compounds with bromine and fluorine, which are thus as relevant as to our health and probably more toxic. The chemists and engineers of the VDE conferences also describe several chemical processes which can lead to the formation of chlorinated dioxins, condensation reaction, substitution reaction, or at higher temperatures even the dechlorination of higher chlorinated PCDF, PCDD to the 4-substituted Seveso poison. In their own words, one further important chain of reaction which leads to the formation of PCDD and PCDF is radical reactions. The process is of importance when burning organic material in the process of organic, inorganic chlorinated compounds and temperatures of 300 to 600 degrees Celsius. If we look at the reaction products of combustion, we observe that along with the main products of combustion, carbon dioxide, carbon monoxide, water and salt acid, in particular aromatic hydrocarbon such as benzene, toluol, xylol, naphthalene, biphenyl, phenanthrene, etc. are formed, which are known to have a high thermal stability. While the formation and emission of aromatic hydrocarbons, PAH, PCB, etc., are played down by the medical experts, they appear here as main products of combustion, a fact that Professor Wassermann and his team have frequently established. The concentration of dioxin in the flue gases of waste incineration plants was said by Dr. Lützke of TÜV Rheinland to be generally in the range of 0.1 to 1000 nanogram per cubic meter. If we assume a mean value of 500 gram per cubic meter and multiply this by 5000 cubic meters flue gas per ton of waste, then by the amount of waste in 24-hour day, and then in a year, it will then become clear how potentially dangerous waste incineration plants can be, only taking the parameter dioxins into account. But we mustn't forget that the regulation, the 17 BImSchV, requires less than 0.1 nanograms per cubic meter, and the medical experts measure us by not doubting that waste incineration plants regularly remain below that limit. B. Taking samples, preparing samples, isolation, identification of sample isomers. Since the flue gas ducts of industrial plants have larger dimensions and the PCDD and PCDF are present, both attached to particles and also as gas, we cannot assume that they are equally dispersed over the cross-section of the duct. For this reason, chemists and engineers demand that portions of the flue gas flow and the dioxins and furans contained in them must be sucked off in the same speed, at several measurement points distributed over the cross-section of the duct and be directed to a suitable collection point. Specifically, they say such grid point measurement should be carried out. It must be the duty of the regulatory authorities to ensure that samples taken in each individual waste incineration plant follow these urgent recommendations of the VDE. The chemists and engineers carefully study chemical factors which interfere with the result of the measurements and which therefore must be taken into consideration during the taking of samples. the influence of the respective temperatures of the steam and of the pH value on the vapor pressure of the various dioxins or furans and their condensation and sorption reactions. They warn that loss through the convection or vaporization of substances or through subsequent nitration by the presence of NO2 must be avoided. Anyone who reads the detailed information from the VDE lectures with a basic understanding of chemistry gets a good impression of the fact that the dioxin results depend on a lot of different factors and can vary greatly. One thing that is conspicuous is that the dioxin measurement is be carried out annually after the first year in service. Should be taken when the plant are working at full capacity. The suspicion arises that waste incinerating plants might emit different concentrations during the interim months when they are not working at full capacity. The recommendation of the VDE also reinforces what we said earlier about the ability of the dioxin of furans to cling to dust and soot, a fact which we illustrated by using indigo dye. To quote from the transcript, there will probably be extremely low vapor pressure in the concentration ratios which occur in practice. Professor Hagenmeier, a vastly experienced dioxin analyst, and his team confirm that. The subsequent procedural steps in the laboratory can be carried out perfectly and the result can still become useless or lead to misinterpretation. In the case of all solid matter samples, fly, ash, slug, sewage, sludge, sediments, solid tissue, samples, etc., the extraction stage, the dissolving of PCDD and PCDF out of a sample matrix, involves a level of uncertainty which cannot be removed even by adding the appropriate internal standard compounds. The regulation 17 BIMSCHV doesn't deal with the technical problems of measurements and requires only measuring procedures and measurement equipment in accordance with the latest technology and the particulars by the authorities responsible. We have no knowledge whether the authorities responsible with their guideline powers follow all the recommendations of the VDE, which were the subject of complex discussions during both of the conferences.